FreePath, digitizing the subsurface, using the GS8000 Pro. Thanks to FreePath, mapping the underground has never been easier. In a few simple steps, we can digitize our subsurface findings and, in real time, generate reports utilizing the power of our software. Let's start with pairing to the equipment. Click on the position tile and connect to the MA8000. Next, we will have to make sure that we choose the correct state plane coordinate system. From here, we will pan back over to the connectivity pane and click Start. This will tell the GPS receiver to start grabbing online corrections. Next, we will navigate to the probe tile and we will connect to the GS8000 antenna. Now that we are connected to the device, we can create a folder for our specific job in the data dashboard. To do this, click on the folder icon in the bottom left corner of the screen, and then name your job accordingly. All of your files for the day will now live inside of this folder. This will make navigating back to old projects much easier. Now we can create a new file by pressing on the plus icon. We are now ready to begin data collection, and before we do so, I like to zoom out and make sure that I'm accurately geo-referenced in the satellite image. Let's take a look and review our GPS corrections. We're in a fixed position, we're using the correct state plane coordinate system, we have 2.5 centimeters of accuracy, 20 of 32 satellites, and you can see the GPR battery status and the GNSS battery status. To begin collecting GPR data, press the teal-colored play button on the screen. You are now off and running. Make sure to densely cover the area for the best possible GPR results. Now that we have collected our data, we can perform a two-finger swipe on the screen and take a look at the B-scan, otherwise known as the radargram. From here we have some options. We can choose to look at the high-frequency data or the low-frequency data. Let's use the A-scan, otherwise known as the oscilloscope, to add tags to each of the hyperbolic responses that were displayed. Hopefully these tags will form a linear relationship when we view them in the C-scan. This object was at a consistent depth and produced a consistent hyperbolic reflection. That indicates to me that it could potentially be an underground utility. As we two-finger swipe and navigate back to the slice view, we will notice that the tags that were placed in the radargram have now populated here at the depth that they were placed at. As I slice down through the data using the thickness slider, you'll notice that the high amplitude reflections caused by the pipe are displayed in red, and the low amplitude reflections caused by the soil containing zero reflectors are displayed in blue. Now that we are comfortable with our results, we can draw in a utility line and designate the pipe as a gas line. We are ready to export our data and generate the deliverable. If you press the share button located below the trash icon, you can view our export options. We have all sorts of options ranging from export as snapshot to exporting as an HTML. Lastly, we can share our project with other users utilizing the share via URL export option. Digitizing the subsurface made easy with the GS8000 Pro.